Welcome to the video tutorial on multiplayer networking using Photon Fusion. This is a really cool topic because anytime you build a game or an environment, you probably want to send it to your friends, and how cool would it be if you could actually play it along with them? That's what Fusion allows us to do. So let's get started by signing up at photonengine.com. Once you've signed in, click Create a New App. This will technically be considered a multiplayer game, so we'll select that. Select the Fusion SDK and Fusion 2. Give your app a name, for example Fusion App, and hit Create. You'll see our app here. It states that we have 20 CCU, that stands for 20 concurrent users. That's how many players your game can support at once. Then we have this app ID. We want to copy that. Let's go over to the asset store and search for Photon Fusion. Download and install, open that in Unity, and import it to your project. This can take a little bit of time. Okay, go ahead and paste that app ID that you copied earlier. Another thing we'll need to do is download the physics add-on for Fusion. So you can just search for this online. This is Fusion Physics 2.0.4. Double click on that to open it in Unity and click Import for all. Or you can drag it into your project and click on it from there. I'll create a few folders here. We want a scripts folder. We know we'll use that. Let's also create a prefabs folder. And then lastly, let's create a materials folder. The next thing I'll do is just create a new scene. I'll use the standard URP template. It has a few things in there that quality of life. I'll go ahead and delete that little Unity sphere. Now if we right click, we can go down to Fusion, Scene, set up networking in the scene. It's going to ask us to save the scene if you haven't already. I'll just overwrite the default sample scene. That should be fine. And as soon as that happens, you'll see there were two game objects added to your scene. One is the prototype network start, and the other is prototype runner. This configures a little UI that shows up when we hit play, and the prototype runner has some events. You can go ahead and click Add Runner Enable Visibility. Let's hit play and see what happens. So we get this little UI. We can type in a room code if we want. This would separate players out based on what room they typed in. Start shared client. So very simply, we did connect to the server. We just don't have a player and nothing's happening. So since we're only going to be using shared mode, we can change the Fusion Bootstrap to be on automatic and shared. This will automatically skip the UI so that when we hit play, automatically starts a shared session. So I have this little pirate character that I created in Modif and rigged in Mixamo. I brought him into the environment. I'll give him a name. Let's immediately turn him into a prefab. We are mainly going to be working with prefabs when we have networked objects. We're going to add a component. I have a Fusion player behavior that I provided for you, so go ahead and add that. You'll notice that as soon as you add it, a few other components have been added as well. So a rigid body, a network rigid body 3D, which you downloaded, and player input. So there is a little warning here, but we can pretty easily fix that by just clicking on that action system, duplicate it and give it another name, anything really. We can go back and reassign that. Now we have our network object, the base of any type of Fusion networked object. It wants us to re-import, but we can just leave our prefab scene, save the scene, and open up a prefab again. That'll get rid of that warning. Of course, we have our Fusion player behavior. We also have a network mech anim animator. We also have an animator which was automatically added, but we don't have a controller yet. You can see that's what that arrow in the bottom left currently is talking about. So we'll go to our animation, create a new player animation controller. And then we'll go back to our player prefab, assign that into our animator. And let's go ahead and organize that controller. Create a folder for animations. So you'll notice we have this camera position transform. Let's go ahead and create an empty game object here that we can hook our camera up into. We don't need to actually create a camera here. We just need to create an empty transform, the position where we want our camera to end up. We are actually going to use the camera that's already in the scene. This lets us do a pretty cool little fly-in animation. So we'll assign that transform to the position. Okay, let's open up our animation controller. Let's create a new blend tree, create state from new blend tree. And from here, let's double click to open up the blend tree. Let's go to our parameters and change that blend parameter into speed, lowercase speed. Let's create two motion fields, just like we usually do for our characters, one for walk and one for idle. You'll see that they are still named mixamo.com, so what we can actually do is go back to the original FBX file. In the animation tab, we can rename it down there where it says mixamo.com. Let's give that the actual name. I'll call it breathing idle. Hit enter and apply. Same with our happy walk. Animation tab. Give it a new name. Hit enter and press apply. This way you don't have to create duplicates of your animations and they stay inside the FBX file. Let's add the next motion field. This is going to be our happy walk. You can choose whether you want to automate the thresholds. Here I'm going to choose not to because I want any motion which is above 0 to begin walking. So 0.1 will probably work here for us. You'll also notice down at the bottom that speed animation parameter actually lets us say what parameter we created. That way, in case we did type capital S speed or anything else, we could just change it there without having to hard code the script and let it reload again. So before we hit play, we need to make sure to remove the player. We don't want any type of orphaned game object. Let's create an empty game object that we can use for our player spawner. I like to put little brackets around the names just so I know it's a special type of game object. This is the Fusion player spawner. Let's assign the player prefab. This is automatically going to sort only prefabs which have a network object component on it. That's why you saw a few of them disappear. Spawn point at 1 since we want him to not be spawning in the ground. And now is as good a time as any to actually add his texture. So you notice that the skin has the skinned mesh renderer. We have to have that selected for us to drag a texture on. Let's remove some of the smoothness and the metallic. Okay, this part's pretty important. We're going to go to our prototype runner and look for the network events. Scroll down until you see player joined. Click the plus to add a new event. We'll drag in our player spawner since that has our player spawner script. Under the function, we'll select the Fusion player spawner and spawn player. This means that anytime a player joins, this is the method which is going to be run. We can go ahead and hit play, see what happens. Surely nothing could go wrong. Okay, looks good so far. Camera controls seem to be working. And, well, that can happen, you know, abandoned ship. The problem was just that we didn't have a capsule collider, so we'll go ahead and add that to the character, size it up, scale it. And let's try that again. Okay, this landlubber has his boots on the ground, except now his animation doesn't loop, so let's go back to fix that. In the same way, we can go back to the FBX file and just select the loop time under animation. We'll enable that and hit apply. Okay, let's give it another shot. Okay, not bad. The scale is a little larger than I intended, so I'll probably go back into the FBX just to change the import scale. So go back to the FBX file. This is under the model. I chose 3. I'm going to guess that 1 is a better value. We'll hit apply. Okay, that's about what I expected. Let's test this out a little bit more. See if his animations loop, if he walks around. Looks like it's about the right speed as well. We can use the scroll wheel to change the field of view on the camera. That's just handled by the player script. Okay, I think this looks pretty good. Let's go ahead and build this to our device. Save your scene, go to File, Build Profiles. Depending on what platform you're on, one will be selected automatically. You want to install both, however, so when you click on Mac OS or Windows, as the case may be, it will ask you to install with Unity Hub, which you probably want to do since eventually you will need to be building for both. Let's go to our project, create a builds folder at the asset level. Here's my builds folder. Let's create a folder for Mac OS as well as Windows. I'm on Windows, so I'm going to build for that. Okay, fast forward a little bit. I have 2 of these clients open. So on the right side, I have the actual build that popped up. On the left side, I have Unity. So usually to test this, you'll have one build open up, and in the other screen, you'll use Unity. The other thing we need to cover is networked variables. So I created a few different variations of the Pirate's Clothes just using paint.net to do a simple hue shift. It's not perfect, but it'll do. So we have some new textures, meaning I created a few new materials as well. Pretty cool. So this is going to necessitate a little bit of a change in our player script. We are going to add a section for an array of materials. We'll have a length of 3 and a reference to the player renderer. We have this new field here called networked, and that indicates that this is a variable which needs to be tracked by the network. It has a get and a set property. And then we also have this onChangedRender. The purpose of this is to say that any time that this variable changed, that's the method which we should use. OnMaterialIndexChanged. And so if we go down to look at that, any time that this networked variable changes, we run a quick check to make sure it's good. For example, that there is a player renderer, that the material index is above 0, and that it's within range. Then we set our player materials to the material index. And so we actually change our material index with this other method here, which is handleMaterialSwitch, This just listens to the keyboard for a press of 1, 2, or 3. If we press 1, we go to index 0. If we press 3, we go to index 2. And so that's going to automatically invoke a change in that variable, which will then invoke the server-side call for everybody else. And so this is a way of describing yourself to the other players. I'll go ahead and select the first outfit that I want him to wear. And then I'll just drag in the other ones since they're in the project pane already. Red, green, and blue. Okay. Let's give it a test and hit play, see what happens. So there seems to be an error. I'm hitting 1, 2, and 3 on my keyboard and nothing is happening. That's probably because I didn't assign a player renderer and the script isn't fetching it automatically. So I could just change the script to automatically make it set the player renderer. We have a player renderer already defined. So in our awake, let's just have it get the player renderer from the children. There we go. That should set it up automatically. Let's save that and go back to our scene. Okay, so I'm going to go ahead and control the character in the build view. I'll hit 1, 2, and 3, and we can see it actually does change the color of his clothes. So we use a networked variable when we want to convey something about the player, their own state, to the other players. But there are other cases, for instance, if you are interacting with another player where we need a different strategy, and these are called RPCs. This is a remote procedure call. And so we use these when we might need permissions or requests to other game objects, as opposed to changing the color of our own clothes and broadcasting that to other players. This is where we might want to invoke a method on another player, but this requires some type of permission or understanding of who's calling this. For instance, if I had a method that said take damage, you probably want to ensure that I'm not just calling that on another player without any good reason. So I can't just change the health of another player directly. I would need to request that the player changes its own health. You probably won't have a need for this right now. However, if in the future you decide to implement some more advanced player interactions, this is pretty common. So you'll notice that the methods are prefixed with a tag that says RPC. We have the source. So for instance, who can call this? And then we have who it affects, the target. So we have RPC, we have input authority, and we also have another for the state authority. That's who it impacts. Above you can see I have another version of that RPC, one which has RPC sources all, meaning anybody can call this, and it affects the user of state authority, which is probably the other player itself. And so again, when might we use this? Typically they are on method calls which are fewer and far between, as opposed to a networked variable, which is expected to be changing constantly. Perhaps we use it also because we want some layer of security behind the method being called. If I had some type of trade method, I wouldn't want you to be able to force that out of my hand by calling that on me. You know, it is my game object, but I didn't agree to the trade, or I didn't agree to have that method run from me. So it's an added layer of protection as well from the clients modifying other game objects that they don't have authority over. So that's the full introduction to multiplayer in Unity using Fusion. If you have any questions, please feel free to reach out. Otherwise, good luck, have fun.